Hello students, and welcome to our lesson on decimals. What we're going to be doing in this lesson is learn how to say decimals out loud, how to turn fractions into decimals by doing long division, how to multiply, add, subtract, and divide decimals, and how to round decimals to specific place values. So a whole lot's going to be happening in this lesson. It might be a little bit of a long one, but hang tight with me. And remember that you're always welcome to pause the video, rewind. If you need to do it in 2 sittings, if it's a little long, then do so. YouTube works great for picking up right where you left off. All right, without further ado, let's go ahead and get into it. So what are decimals? In the last lesson, we worked with mixed numbers like 3 and 4 tenths, or 7 and 25 out of 100, or 25 hundredths is how we're going to say that in a minute. So decimals are just another way to express the value of mixed numbers and of fractions. So mixed numbers have both a whole part and a fraction, but of course, if there is no whole part, then we just have a fraction. So decimals are going to be a different way to express that same value. The decimal point is going to separate the whole part from the fraction part. And what it's going to allow us to do is, I don't want to necessarily say work with numbers easier, but there are certain numbers that are more convenient as decimals than they are as fractions or mixed numbers. So depending on the situation, we may prefer a fraction or we may prefer a decimal. But knowing how to easily convert between them is what's going to make it so we can use either all throughout our lives, and especially throughout our math classes. All right, so let's go ahead and turn fractions into decimals real quick. So you notice numbers 1 through 3 there. We have numerators and denominators, but the denominators are all powers of 10. So specifically for these first few, we're just going to be working with powers of 10 on the denominator. That way this long division is going to be nice and simple. So number 1, we're going to use long division to turn 3 over 10 into a decimal. So what we're going to do is divide 3 by 10. So normal long division here, just like we did in lesson 1 for essential skills. The only thing that's special is that notice 10 is bigger than 3. So I can't divide 3 by 10, at least not in the current form. What I have to do is add some imaginary zeros after the 3. And I don't know how many I need, so for now I'll put 3 of them. That may be too many, we'll find out. But notice I also put that decimal place after the 3. So this number I wrote here, 3.000, is still just equal to 3. If I did not put the decimal place, then this would say 3,000, and that's a different number than 3. But by having the decimal and then 3 zeros, this is still just the number 3. All right, so now we are going to do long division pretending that the decimal place is not there. So we're going to skip over the 3 because 10 does not divide 3, but 10 does go into 30. So above the first 0, which is going to represent 30, I'm going to put a 3 on top, and then we're going to multiply 3 times 10 and subtract 30 down below. When I do 30 minus 30, that is just going to give me 0. And so once I have a 0 here, I actually don't need these other 2 zeros I had written. So I put too many zeros there. But that's okay. We're actually done with this one. Now we just have to know where the decimal place goes. So when you do division with whole numbers, the decimal place is always going to go directly above where it is in the dividend. So right above, so see the decimal was here, I go straight up and put it right in front. And then we can put a 0 in front of the decimal place just to make it clear that there is no whole part. And so our quotient is that 3 over 10 is equal to 0.3. Okay, we just go ahead and do that long division, put the decimal place right above where it was in the dividend, and that 0 in front just makes it clear that this is a decimal, because sometimes the handwriting is a little hard to read with that decimal place, so putting the 0 makes it clear. All right, let's try number 2. We're going to have a bigger number on bottom now, but the process is the same. We're dividing 47 by 100, so I'm going to put 47 inside the box and 100 on the outside. Because 47 is smaller than 100, I'm going to have to add some decimal places to this. So I'm going to put 3 here. I don't know how many I'll need, so I'll just put 3 for now, and we can always get rid of a couple if we don't need them. But again, notice that 47.000 is just 47 still. It does not change the value of it. It just gives me more place values to work with. So now we start dividing. 100 does not go into 47, but it does go into 470. And it goes into 470 4 times. So I'm going to go ahead and put a 4 on top. 4 times 100 is 400, so I subtract that down below. I end up with 70 left over. And then I'm going to drop down the next 0 that I had as a placeholder. That way, just like normal long division, I have that next digit ready to go. So now we have to divide 700 by 100. That gives me 7. So I put a 7 on top. 7 times 100 is 700, so I subtract 700 down below. And since that gives me 0, that tells me that I am done. I do not actually need that third 0 that I had prepared. So now to write our answer, all we do is put the decimal place right above where it already was, and then I'm going to put a 0 in front just to make it clear that we have a decimal. So we would then say that 47 over 100 is equal to 0.47. All right, one more. We're going to do 256 divided by 1,000. So I'm going to set it up exactly the same. 1,000 on the outside, 256 on the inside of the box. And since 256 is smaller than 1,000, I'm going to once again add a few extra zeros. That way I have place values to work with. Now we just start doing the long division. 256 is not big enough to divide by 1,000. So we include that next 0 I had written. So now it's 2,560. 1,000 goes into 2,560 2 times. So I write a 2 above that 0. 2 times 1,000 is 2,000. So I'm going to subtract 2,000. That leaves me with 560. And then I'm going to drop down that next 0. So now we divide 5,600 by 1,000. That's going to be 5 is how many times 1,000 goes into 5,600. So I multiply 5 times 1,000, which is 5,000. And we subtract down below to end up with 600 as our current remainder. But we can drop down another 0 and keep going. So when I drop down this third 0, I now have 6,000. 1,000 goes into 6,000 6 times. So I put a 6 on top, subtract 6 times 1,000, which is 6,000 down below. And that just leaves me with 0, so I am now done. I can put my decimal place right above where it was in the dividend and put a 0 in front. And I can conclude that 256 divided by 1,000 is equal to 0.256. So now what I want you to notice is that when we divide by powers of 10, notice that all we had to do was take the numerator and move the decimal over a little bit. So 3 divided by 10 was just 0.3, where all we had to do was take the decimal place from the 3 right here and move it one spot to the left. So that gave us 0.3. When I divided 47 by 100, because 100 has 2 zeros on it, I moved the decimal place twice to the side. And so that's how I end up with 0.47. Same thing with 256 divided by 1,000. I move the decimal place 3 times, so I get 0.256. So now this is going to show us why decimals are called what they are. Okay, I purposely chose powers of 10 because that's how the place values are going to be named. Notice that our first problem here, number 1, was 3 divided by 10. If we have 1 divided by 10 instead of the 3 on top, that would have given us 0.1. So instead of 0.3, we'd have 0.1. So now the name comes from this fraction. Okay, when we have one decimal place, we call that the tenths position with a th at the end of the word 10. And it is because we get that decimal 0.1 by dividing by 10. So 1 over 10 is 1/10. Similarly, 3 over 10 is 3/10. Okay. For division by 100, we can say that 1 over 100 is 1/100th, where it's 100, but with a th at the end, 1/100th. So if we have 0.47, which is 47 over 100, we would call this decimal 47/100ths, okay, because it's 47 over 100. So that denominator is telling us how to say the decimal out loud. Okay, similarly, 1 over 1,000 is 1,000th. Notice that's 3 decimal places where the 1 goes. So it's 001 gives us 1,000th. So similarly, 256 over 1,000 is 256 thousandths. Okay, where when we have 1000 on bottom, that tells us how to name that decimal. So now what we're going to be doing to name decimals is we're going to be taking the rightmost place value and using this chart of place values to tell us how to name that decimal. So the name of a decimal comes from the fraction component of the number, and it is the rightmost decimal place or the rightmost place value. So for example, if we had 4.3, we just saw that 0.3 is 3 over 10. All right, and the 4 is the whole part. That's what's in front of the decimal, so that's just a normal whole number. So as a mixed number, we would call this 4 and 3/10, because we name the whole part, just 4 is 4, just like always, but then we name the decimal part based on what the fraction would look like. So it's 4 and 3/10. Okay, 4.3, the 3 is in the tenths position because it's the first decimal place. So we call it 3/10. Similarly, if we have 0.38, that is 0 and 38 over 100. Okay, where we get 38 over 100 because the second decimal place value is the hundredths spot. Okay, when we divide by 100, that's going to give us that second decimal place. So we call this the number on top over whatever this number on bottom is. So in this case, 38 hundredths, because it's 38 over 100. And as a decimal, we don't have to see the fraction to name it. All we have to do is know what place value is the rightmost place value. So where is that 8? That 8 is in the hundredths position. So we call it 38 hundredths. All right, so let's go ahead and try with a few examples down below. We're going to use that chart up there. So our first number is 5.07 down here for number 4. So what I'm going to do is take 5.07 and throw it into that chart. So the 5 is in the ones place, then we have a decimal, and then 0.7. The way we name numbers is the whole number first. So the whole number component of this is just 5. When we get to the decimal place, we say and, which is why we did not use the word and when naming whole numbers. It only shows up with decimals. So it's 5 and 0.07. If we look over at the chart, the rightmost place value is the hundredths. So we say the name of these digits, 0.7, is just 7. Okay, the 0 doesn't add any value here. We just call this 7, but then we name this place value. So it's 7 hundredths. So our number is 5 and 7 hundredths. And don't forget the TH on the hundredths. All right, let's try again with number 5. We have 12.305. So we're going to write this in the place value chart. 12.305. The way we name it is we name the whole number, which is just 12. Then we say and. So it's 12 and, well, 12 and what? If we wanted to turn that 0.305 back into a fraction, we would just take the 305 and put it over 1000. Because we have 3 decimal places, and the third decimal place in this chart is the thousandths place. So we can go ahead and name this number as 305 thousandths. Okay, so we have 12 and we name the top digits 305, and then we name that place value, which is the denominator of the fraction. So 12 and 305 thousandths. So it's 1,000 with a THS at the end. 12 and 305 thousandths. And specifically as a mixed number, this would be 12 and 305 over 1,000. The first one would have been 5 and 7 over 10, because that 7 over 100, because that 7 is in the hundredths position. So notice the name 7 hundredths matches this fraction, 7 over 100. And for the second one, the name 305 thousandths matches this fraction, 305 over 1000. All right, we can keep going a little deeper though. We have more place values than that. So this next number is 0.0 0.0006. All we have to do is look at the rightmost place value, which in our chart right here is going to be the 10,000s place. Notice, by the way, that the name of the place values for decimals goes in the exact same order that it goes for whole numbers. We go from tenths to hundredths to thousandths to 10,000ths, and then we would have 100,000ths and millionths if we kept going. So the only place we skip is the ones place, but otherwise we have all the same place values. So right now, this 6 is our rightmost digit, and it's in the 10,000s place. So if we wanted to write this as a fraction, this would just be 6 over 10,000. So when we name this decimal, there is no whole number part. So all we have to do is name that decimal or that fraction. We would say that this is 6 10,000ths, where we name the digit on top, in this case just 6, but no matter what that number on top is, we name it as if it's a whole number, so just 6 in this case. And then we say the place value, which corresponds to the denominator of the fraction. So because that place value of the 6 is in the 10,000 spot, we call this 6 10,000ths. And again, th at the end of 10,000. All right, so now let's go ahead and work on comparing decimals. Now that we know how to name them, let's go ahead and actually put them in order from least to greatest. So what you have to do to compare decimals is line up the decimal places. So what we're going to do is write them right on top of each other with the decimal points lined up. And then we go place value by place value to compare. The first different digit is going to tell us which number is bigger. Okay, so we go place value by place value. Once a digit is different from left to right, that tells us which number is bigger. So for number 7, I'm just going to take these two numbers, 0.53 and 0.503, and see how I wrote them right on top of each other with the decimal places lined up. And then we just go place value by place value. They both have a 0, so that's the same. They both have a 5 in the 10th spot, so that's the same. But then in the hundredths position, one of these has a 3 and one has a 0. So the number that has the bigger value in the first different place value is the bigger number. So because 3 is bigger than 0, we would say that the top number is bigger than the bottom number. So we can just go ahead and conclude that 0.53 is greater than 0.503. And again, we're just comparing place value by place value until we find what's different. So number 8, we're going to order these from least to greatest. So I'm going to write them right on top of each other first. 3.12, which is 3 and 12 hundredths. Then we have 3.102, which is 3 and 102 thousandths. And then we have 3.2, which is 3 and 2 tenths. All right, so now we compare place value by place value. They all have a 3 in front, but we notice that one of these numbers has a 2 in the tenths position, and that is bigger than the other two numbers. So that 3.2 is going to be our biggest number because 2 is bigger than the ones. And then we look at the next place value to compare the last two numbers. We have a 2 and a 0, so the 2 is bigger than the 0, which means 3.12 is going to be bigger than 3.102. So we took 3.2 first because it had a 2 in the tenths position, so it was the biggest. Then we were only comparing these top two numbers, but a 2 in the hundredths position is bigger than a 0, so 3.12 was bigger than 3.102. So comparing numbers is really just a matter of going place value by place value. All right, now let's talk about rounding. To round decimals, we're going to find the place value and look one place to the right. So just like rounding whole numbers, we find the place value we care about and we look one digit to the right. If the digit is 5 or more, we're going to round up. Otherwise, we're going to keep the digit the same, which means to round down. Unlike whole numbers, though, digits are ignored to the right of the place value we rounded to. So we do not replace them with zeros. Okay, when we round, we are making our number less accurate. And so we do not want to put those zeros because that implies our number is more accurate than it actually is. So you can see that last bullet point, This reason, or the reason we do not write those extra zeros, is because those extra zeros to the right of the decimal place do not change the value of the number, but including them implies, okay, this word implies tells us that our number is more accurate than it is. So 4.5 is the same as 4.500, but when we write those extra zeros, it implies that we actually measured to the nearest thousands place, which is that last zero. So if I only measure to the tenths position, but I write these two extra zeros, I'm almost lying about how accurate my number is. Okay, so we do not want to write extra zeros unless we are actually rounding to that place value. Otherwise, if we're rounding to the nearest tenths, we would just write 4.5. So now a couple examples just show you the difference between this rounding, between whole numbers and decimals. If we want to round 47,382 to the nearest 10, that is the 8 in this number, then the number next to it is a 2, so we would round down and just round it to 47,380, where 82 became 80. But we write that 0 there. Okay, we actually put that 0 at the end, because if we don't put that 0, it says 4,738, which is different than 47,380. So that 0 has value. That tells us the number is in the 10,000s, not just in the 1,000s. But if we want to round the same digits but as a decimal, 47 and 382 thousandths to the nearest tenth, which is where this 3 is, the number next to it is an 8, so we would round up. So that 3 becomes a 4, but notice we do not put two extra zeros there. Okay, even though we had two extra digits on the original number, if we put those two extra zeros, it implies that we rounded to the nearest thousandth, when in reality we rounded to the nearest tenth. So we don't put those extra zeros, we just ignore them. All right, let's do a couple examples. Number 9, we want to round 3 and 478 thousandths to the nearest hundredth. So I'm going to take my number and I'm going to identify where the nearest hundredth is, or at least identify where the hundredths place value is. It's that 7. The number next to it is an 8. So I'm going to round up to be 80 at the end here. So my number would be 3.480. But because this is a decimal, I don't put that 0 at the end. I just put 3.48. So when something tells us to round to the nearest hundredth, our answer should stop at the hundredths position. We don't put that extra 0. Number 10, we want to round 82 and 959 thousandths to the nearest tenth. So I'm going to take the number and I'm going to identify the tenths position. That's where this 9 is. The number next to it is a 5, so we're going to round up. So that 9 is going to become a 10. But when it becomes a 10, we have to add the 1 to the next column. So the 0 stays there, but the 1 goes to the next one and makes that 2 a 3. So we actually end up with the number 83.0, where notice that the 0 is in the tenths position, and that's what we were rounding to. So even though it's a 0 at a decimal, because we were rounding to that position, we do write that 0. And the only reason the 2 changed to be a 3 was because the 9 had to carry over because it was too big. And we're going to see that again. Round 19 and 995 thousandths to the nearest whole number. Whole number means to the ones position. So we're going to round 19.995 to where that first 9 is. That's the nearest whole number, or the ones position. The number next to it is a 9. So we're going to round the ones position up to be 10. But just like the previous one, that 10 has to carry over to make the 1 a 2. So we're going to end up with 20 as our answer, where we don't write any zeros after 20, because the nearest whole number means to round to that ones position, so we should not have any digits past the ones position. We stop right there at 20. All right, now we're going to get into the actual arithmetic of this, and I am well aware that most people are going to use a calculator for most situations involving decimals. I totally understand that. However, we still need to know how to do these things by hand. So even if you're telling yourself right now, I'm always going to use a calculator, you still need to know how. So let's go ahead and go through all the different operations we can do with decimals, and make sure that we actually know the process for what to do. So step one for adding and subtracting decimals is just line up the decimal places. Then we're going to add or subtract as if they were whole numbers. So we're just going to ignore the decimals. Okay, we're just going to treat them as whole numbers. And then wherever the decimal place is, we're going to bring it straight down into our answer. So for number 12, 14.52 is 14 and 52 hundredths. And we're going to add 3.8, which is 3 and 8 tenths. So I'm going to write the numbers right on top of each other so that the decimal places line up. So now notice that these have different numbers of decimal places. We have a 2 in the hundredths position, but then we have a blank spot in the hundredths position for the next number. So what you're going to do is put a 0 there because 3.80 is the same as 3.8 in value, but now we actually have a number in that place value, so we know what to add with. So now we're just going to add as if the decimals don't exist. Pretend it's 1,452 plus 380. So we would add the 2 and the 0 to get 2. The 5 and the 8 gives us 13, so I carry a 1. 4 plus 1 plus 3 gives us 8. And then a 1 is just a 1. But now, because they were decimals, we bring that decimal point straight down into our answer, so we get 18.32. So now, how do you know that you put the decimal place in the right spot? Well, just estimate this with whole numbers. So at the beginning, if we ignore these decimal places, if I just told you to add 14 and 3, that would be 17. So we know that our answer should be pretty close to 17 because although those decimals are going to add value to it, they're not going to add a whole lot of value because they're behind the ones place. So this is basically 14 plus 3, which is 17. So I know going into this that I should have a number pretty close to 17, and 18.32 is pretty close to 17. And what I mean here by pretty close is they are both 2-digit whole numbers, but then there's just some change at the end. And I call it change because when we talk about money, the decimal place represents cents, or the coins that we would normally use. So literally the change. All right, number 13, we're going to subtract now. So we're going to do the exact same process. We're going to write the numbers right above each other where our decimal places are lined up. So we have 23 and 7 hundredths subtracting 5 and 892 thousandths. And just like before, we have a place value missing. So I'm going to put a 0 there to fill in the gap. And remember, I'm allowed to put that 0 there because it does not change the value of the number by adding a 0 at the end. It just makes it appear to be more accurate than it actually is. All right, now we subtract as normal. This one's going to be a little bit messy because we have some big numbers on the bottom and some not so big numbers on top, but it's going to test our subtraction skills. That's okay. We start off with 0 minus 2 in the first column. So that 0 is not big enough. I'm going to steal one from the next column to make it a 6 in the second column and a 10 right there. So we do 10 minus 2 is 8. And then we move on to the next spot. We have 6 minus 9. Okay, well 6 is not big enough, so I'm going to make it a 16, which means I have to steal one from the next column, so it becomes a 9. Okay, because a 0 means it was 10, but now it goes down one to be 9. But because we had to make it a 9, we had to steal one also from this 3. So that becomes a 2. A lot of subtraction math there. All right, so now in that second column, we have 16 minus 9, that is 7. Then we have 9 minus 8 gives us 1. 2 minus 5, well, 2 is not big enough, so we steal one again to make it 12, and that makes it a 1 in the first column. So now we're doing 12 minus 5 is 7, and 1 minus nothing is just 1. Then I drop my decimal place straight down, and I get 17.178. So now again, how do I make sure that I didn't make any mistake with where my decimal should be? Well, we just approximate. If I told you to do 23 minus 6, 23 minus 6 would be 17. And notice that our number is 17 and some change. So we know based on the size of our number when we estimated that we have the right number of place values there in the front. All right, so that's adding and subtracting. Now let's get to multiplying, which I think is a little bit more insightful because we get to talk about fractions again and why this process is going to be what it is. So what we're going to do is we're going to multiply as if the numbers were whole numbers. So when we multiply decimals, we ignore the decimals for a second. But then we're going to go back and we're going to count the total number of decimal places in the factors. So the two numbers being multiplied together, we're going to count the total number of decimal places. And then we're going to place the decimal in the product so it has the same number of decimal places that we counted in the previous step. But why? Why is this going to work? Okay, so let's look at this math in the middle of the page here. If I have 0.2 times 0.35, that is 2/10 times 35 hundredths. Okay, no big deal. We turned decimals into fractions. That's just a matter of knowing how to name them. So again, 0.2 is 2 over 10 because the 2 is in the tenths position. And 0.35 is 35 over 100 because the 5 is in the hundredths position. But now look at how we multiply fractions. We learned in previous lessons that you multiply across the top and across the bottom. So we're going to do 2 times 35 on top, that's 70. And then we're going to do 10 times 100 on bottom, that's 1000. Okay, but let's think about what just happened here. The original digits were a 2 and a 35, and on top we're doing 2 times 35. So all we're doing is multiplying those digits as if they were whole numbers. But then we have to put 1000 on bottom, meaning divide by 1000. Well, why 1000? Well, we have one decimal place in the first number and two decimal places in the second number. So in total, that's three decimal places. And notice that 1000 as a denominator will make it so we have a number or a digit in the thousands place, because that's how we turn numbers into decimals, right? 70 over 1000 is the same thing as being 0.070, where notice that that last digit is in the thousands place because we have 1000 on bottom. And so all we have to actually do to multiply decimals is multiply the digits as if they were whole numbers and then put in the correct number of place values. All right, so let's see that for number 14. Number 14, we have 3/10 times 6/10. So I'm going to multiply just the actual digits. Okay, 3 times 6 in this place. So I'm going to write the whole thing out. A little spacing issue there. 0.3 times 0.6. But I'm just going to pretend that decimal place is not there in either number. So when I multiply, I'm just going to do 6 times 3, which is 18. So I have to carry the 1. 6 times 0 is 0, but plus 1 just gives me 18 down there. Okay, cool. Then I would do a 0 here and then multiply 0 times 3 and 0 times 0. But notice that doesn't actually give me anything, right? Those are just zeros. So when I add this all up, I just end up with 18 again. So that last step was unnecessary because we multiplied by 0. Okay, but now the answer is not 18, right? We had 0.3 times 0.6. The answer is not 18. But if we count the decimal places in the original problem, we had one decimal in the first number and one decimal in the second number. So my solution needs to have two decimals. So all I'm going to do is go to that 0.18, or sorry, that 18 at the bottom, and make it 0.18 by putting my decimal spot so that there are two digits behind the decimal place. So I can then conclude that 0.3 times 0.6 is 0.18, where again, my answer, my product here, has two decimal places because the original two numbers had a total of two decimal places. All right, let's do this with a couple more decimal places now. We have 4.2 times 1.53, or 4 and 2/10, multiplied by 1 and 53 hundredths. I want you to always put the number with more place values on top. So because 1.53 has 3 place values and 4.2 only has 2, I'm going to write 1.53 on top and 4.2 on bottom. But now when I multiply, I'm going to completely ignore those decimals. So I'm just going to multiply 153 times 42. So 3 times 2 is 6. 5 times 2 is 10. I carry a 1. 2 times 1 is 2. Plus 1 gives me 3. Then I go down a spot. I need to put a 0 first. Then 4 times 3 is 12. So I carry a 1. 4 times 5 is 20. Plus 1 is 21. So I carry a 2. and then 4 times 1 is 4, plus 2 is 6. When I add these all up, I have 6, 2, 4, 6. And now I go back and I count how many decimal places I should have. So my original numbers had 1 decimal in the first number and 2 in the second number. So that is a total of 3 decimals. And so in my answer, I'm just going to put the decimal place so that I have 3 decimal place values. So what this tells me is that 4.2 times 1.53 is equal to 6.426, where I have 3 decimal places in my answer because my original factors had a total of 3 decimal places. All right, we are officially done with what I consider to be the easier part of the lesson, where we're adding, subtracting, and multiplying, a little bit of rounding in there. Now we're going to do division of decimals. And let me just warn you that when we do division of decimals, I am once again well aware that almost all of us would pull out a calculator to do this. And I will even give you that I would probably pull out a calculator to do most of these problems. However, when we have simple enough divisors, which number 16 is going to have a simple divisor, then I still think it's much faster and easier for you to do this by hand. Because the time it's going to take me to do number 16 in my head is a lot faster than the way I could pull out a calculator and type it in. Number 17, on the other hand, different story. I would probably pull out a calculator for 17. So I'm not saying calculators are bad, but I am saying that there are situations where we should still be able to do these things by hand, and it is still easier to do it by hand in some cases. So let's go ahead and see how division by decimals works. To avoid division by a decimal, which might seem like a weird way to start this sentence considering I'm saying we're dividing decimals, but to avoid division by a decimal, what we're going to do is use an equivalent fraction. So now, equivalent fractions, we've seen that before. We know how to turn a fraction into a different fraction that's equivalent by just multiplying the numerator and denominator by the same value. But the reason we're going to be doing that is to get rid of decimal places. So we're going to multiply the numerator and denominator by a power of 10 to remove all the decimals from the denominator. Then we're going to compute the quotient using long division and place the decimal straight above where it is in the dividend. So what I mean by all this, when we write this division symbol in between two numbers, that's the same as writing a fraction. So 1.2 divided by 0.3 is the same as 1.2 in the numerator and 0.3 in the denominator. When we say to divide, what we really mean is make this denominator a 1 by finding an equivalent fraction that has a 1 in the denominator. So what we can do, instead of thinking about it as 1.2 over 0.3, if I multiply top and bottom both by 10, that's going to turn 1.2 into 12 and 0.3 into 3. Okay, because multiplying by 10 just moves the decimal point one spot to the right. Now, we all know how to do 12 divided by 3. That's just going to give us 4. And so notice, a problem that started off looking tricky, 1.2 divided by 0.3, is actually equivalent to just 12 divided by 3, which is 4. And so number 16 is going to be just like this, where some problems with decimals look tricky when you have them in decimal form, but if we find an equivalent problem, sometimes that problem is very easy to solve. So watch what happens in number 16. We have 3.6, or 3 6/10, divided by 6/10. So what we're really doing here is dividing 3.6 by 0.6, which means we're going to try to write that fraction with a denominator of 1. And to be clear, what I mean by write it with a denominator of 1 is notice in my previous example up here at the top where I wrote 4, 4 is actually 4 over 1. All right, so we turned 1.2 over 0.3 into 4 over 1. So we made the denominator 1. So what we want to do here, 3.6 divided by 0.6, is find a new fraction that's equivalent with a denominator of 1. But the way we actually do that is by doing long division. All right, so now the only reason we're doing this multiplying by 10 stuff is to make it so we don't have to do long division with a decimal on the outside. If I were to set this problem up right now, it would look like 3.6 on the inside and 0.6 on the outside. But that means we have 2 digits on the outside, and we don't want that. Instead, what I'm going to do is find an equivalent fraction by multiplying top and bottom here by 10. That is going to turn this problem into 36 over 6. And I know how to do that division, right? 36 divided by 6. Well, 6 does not go into 3, but 6 does go into 36 6 times. I subtract 6 times 6 down below. I get a remainder of 0. And so I can go ahead and stop and say that 36 over 6 is just 6. So that means that 3.6 divided by 0.6 is just equal to 6. All right, now, where did we put the decimal? Well, 36 had a decimal place technically right after the 6. So that decimal went straight up to be 6 point, and there could be a 0 there. But because we had no more place values, we don't write the decimal or the 0. So we just write 6. That's going to be different in number 17 right here. So let's see a harder one. For 17, we have 4 and 234 thousandths divided by 5 hundredths. When we write this as a fraction, it's 4.234 on top and 0.05 on bottom. I want to make the denominator a whole number, so I have to move this decimal twice to the right. To move it twice, I have to multiply by 100. So I'm going to multiply top and bottom by 100, and this is going to give me a new fraction, 423.4, or 423 and 4 tenths, divided by 5. Because when I move that decimal place twice to the right, it just becomes 5 point, and then we have no more decimal places. So those zeros in front actually go away when I convert it. So now when I work out this long division, I just have a single digit on the outside. I have 423.4 on the inside and just the number 5 on the outside. And let me tell you, we like when the divisor is a single digit. That was why we worked on our times table so much, is so when we have a single digit divisor, we don't have to think about what all the multiples of 5 are. We should just know them. So when I now do the long division, 5 does not go into 4, but 5 does go into 42. So I write an 8 on top because I know that 5 times 8 is 40, and I subtract 40 down below. That leaves me with 2, and then I'm going to drop down the next digit, which is a 3. 5 goes into 23 4 times because 5 times 4 is 20. So I subtract 20 down below. I get 3 left over, and I drop down that next digit. That next digit is a 4. So now I ask, how many times does 5 go into 34? That is 6 times, because 5 times 6 gives me 30. So I subtract 30 down below. That leaves me with a 4. And now in the past, we would have said that our answer is going to have a remainder of 4. But that's not what we're doing here, okay? We are calculating specific decimals, so we have to keep going. So we need to add a fake 0 next to this 4, and then drop that 0 all the way down, so that way we can keep going. So now 5 goes into 40 8 times. I put an 8 up top and subtract 40 down below. And because I have a remainder of 0 now, and I have no digits left, we are done. But now, when we write our answer, we have to put the decimal directly above where it is in the problem. So right here in the dividend, we have the decimal between the 3 and the 4. It's going to go straight up and go between the 4 and the 6. So it's very important that you write neatly and right above previous statements. That way you know where that decimal point is going to go. So we can then go ahead and conclude here that 4.234 divided by 0.05 is equal to 84.68, or 84 and 68 hundredths. All right, now let's do a couple applications. Now that we've seen all the arithmetic, let's put it into context. So let's pretend that gas costs $3.85 per gallon. How much does 9.5 gallons of gas cost? I am well aware that you can pull out a calculator here and go ahead and just type in 3.85 multiplied by 9.5, and that's going to give you 36.575. That's fantastic, okay, and we can use that to check our work, but we need to make sure we are practicing doing this by hand. So what we're going to do is write it out as 3.85 multiplied by 9.5, where I'm going to put the number with more digits on top to make the multiplication easier. And then we go ahead and just multiply as if these were whole numbers. 5 times 5 is 25, carry a 2. 5 times 8 is 40, plus 2 is 42, so we carry a 4. 5 times 3 is 15, plus 4 gives me 19. Then I put a 0, and now I do the 9 times everything. 9 times 5 is 45, carry a 4. 9 times 8 is 72, plus 4 is 76, so I carry a 7. 9 times 3 is 27, plus 7 is 34. And then I just go ahead and add digit by digit. So 5 plus 0 is 5, then we have 7. 9 plus 6 is 15, so I have to carry a 1. 1 plus 1 plus 4 is 6, and 3 is just 3. So now, in my answer, my product, I have to put the correct number of place values. My original problem had 2 place values from the first number and 1 from the second number. So I need 3 decimal place values in my solution. So this is going to be 36.575. And notice that's the same thing we got when we did this on the calculator, 36.575, which is the same as 36 and 575 thousandths. But we have context now, okay? This is gas price. Is there any such thing as half a penny? At least as far as I know, we do not have a coin for that. And so this answer is not good enough. In real life, we're going to have to convert this to not be 36.575, but we're going to have to round to the nearest hundredth because that is how our money system works. If the price comes out to 0.575, you're actually going to pay 58 cents, not 57.5 cents. So we're going to round this to the nearest hundredth and make it $36.58 is the actual price we're going to pay. So real life context here tells me to round to the nearest hundredth whenever it's money. All right, number 19. A runner completes 26.2 miles in 3.5 hours. What is the runner's average speed to the nearest tenth of a mile per hour? So we're going to calculate this division to find out how many hours each mile takes, but then we're going to round to the nearest tenth. And the reason for that is that if we type this into a calculator, what we're going to notice is that we have way too many decimal places. 26.2 divided by 3.5. See how those decimals just keep on going? 7.485714286. We don't have time to go into that many place values when we do division. So in this case, we're going to go to the nearest tenth, which means we will stop our division process once we get to the hundredths spot, because that will give us enough information to round to the nearest tenth. So now if you're thinking, Mr. K, you already have the answer there on the calculator. Why are we doing this by hand? For practice, because we are learning math, guys. Don't rely on your calculators too much. Although in this case, I probably would have pulled out a calculator to do that math in real life. But we still got to learn. So we're going to do 26.2 divided. Getting ahead of myself there. This as a fraction, this division, is 26.2 over 3.5. So we're not going to do 26.2 divided by 3.5. That would be crazy. Instead, we're going to multiply top and bottom by 10 here. And what we're actually going to do is do 262 divided by 35. All right, so we can write this long division problem down. It's 262 divided by 35 on the outside. So now, why would I use a calculator for this? Well, because it's a 2-digit number on the outside. Our divisor is 35 now. I don't like dividing by things that are not single digits, because in order to do long division, we need to know what the first 9 multiples of the divisor are. So in order to make this problem easier on us, I'm going to actually write out the first 9 multiples of 35. So 35 times 0 would be 0. 35 times 1 is 35. Times 2 is 70. Times 3 is 105. Times 4 is 140. Times 5 is 175. If it's unclear, what I'm doing is adding 35 each time, okay, to multiply by a higher power. After 175, then we have 210. Then we have 245. Then we have 280. And then 315. So This is what we get if we multiply 35 times 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Normally, when we do long division, it's a single digit divisor, so we're supposed to know the multiples of that divisor just off the top of our heads. That's what the essential skills lesson was for, was to practice that. But when it's a bigger number, we don't have all the multiples of 35 memorized, most likely. So having them ready on the side is going to make this a lot easier. All right, so now let's go ahead and look at the problem. We have 262 divided by 35. 35 does not go into 2, and 35 does not go into 26. 35 does go into 262 though. So I'm going to reference my multiples here and say 262 is between 245 and 280. So that means I default to the smaller one. A 7 is going to give me a 245 when I multiply. So I'm going to put 7 on top of the 2. And when I multiply 7 times 35, I'm going to get 245. And again, I know that because I wrote it out on the side already. Otherwise, I would have to guess what multiple works. So I would have to guess 7 and then multiply it out to find out. All right, since we know it's 7, I can go ahead and subtract now. When I do 262 minus 245, that's going to give me 17. And I need an extra digit now to drop down, so I'm going to write after the 2 a 0.0 and drop that 0 down. So now we're going to ask ourselves, how many times does 35 go into 170? So using my multiples on the side, 170 is between 175 and 140. So I'm going to default to the smaller one. And so 4 on top is going to give us 140 as our multiple. So I write a 4 up top, and then I'll subtract 140. That leaves me with 30. And then I'm going to have to drop down another 0. So I have to put in this imaginary 0 and then drop it down. Now, we want to know how many times 35 goes into 300. So I reference my chart over here. I have that 300 is between 280 and 315. So since 8 is the multiple that gives me 280, I'm going to write an 8 up top. And then I'm going to be subtracting 280 down below. And I don't actually care that this result is 20, because in order to round to the nearest tenth, I only have to divide until I get to the hundredths position. So although this decimal would keep going, we're going to go ahead and stop here and say that this division gives us 7.48. All right. And when we round 7.48 to the nearest tenth in this case, 7.48 or 7 and 48 hundredths is going to round to be 7 and 5 tenths. And so when we work out this division, we are going to end up answering as 7.5 or 7 and 5 tenths miles per hour. So now, to be clear, we saw on the calculator, it's actually 7.48577142, and it's going to keep going. But if we only need to be accurate to the nearest tenth, all we have to do is divide until we get to the hundredth spot, and then we can stop. So one of the reasons that I don't always pull out a calculator to do these things is if I know I'm going to round my answer to a nearest whole number or nearest tenth, something that's pretty easy to get to, then I don't need the calculator to give me all those extra decimals. I can just estimate that this is about 7.5 and move on with my life in most cases. So it all depends how specific you need to be. If this problem, instead of saying nearest tenth, said nearest 10,000th, we would have had to keep going for quite a while. And in that case, I would have pulled out the calculator and said, okay, 10,000ths place, that's the 7, so this is 7.4857. And I would have stopped there. But because it was just nearest tenth, it wasn't too hard to actually work out the first 3 digits and then round to be 7.5 miles per hour. All right, last thing is the thing I do most in real life, which is comparing what is called unit cost. So Jackson buys a pack of 24 water bottles for $7.92. Steve buys a pack of 32 bottles for $8. Find the unit cost per bottle in each case, and then say who got the better deal. So we're going to do 2 long division problems. We're going to divide $7.92 by 24, and we're also going to divide $8 by 32. So now neither of these is a particularly easy division problem because we have 2-digit divisors. So this is a situation where if I'm in the grocery store, I'm probably going to pull out my phone real quick to calculate this because I don't have paper to work it out. But when you do have paper, not too hard to get through this. The first few multiples of 24 are 24, then 48, then 72, and that is going to be all we need for this problem, but we could write out all 9 of them. So 24 does not go into 7, but 24 does go into 79, and it goes into 79 3 times, because as you can see on the left there, 72 is the third multiple of 24. So I'm going to go ahead and subtract 72. That leaves me with a 7, and I'll drop down the 2. Now 24 goes into 72, also 3 times. And if I subtract 72 down below, I get a remainder of 0, so I'm done. 7.92 divided by 24 is 0.33. And so we know that this gives us 33 cents per bottle. Okay, when you divide the dollars by the number of bottles, you get dollars per bottle. Or in this case, 33 cents per bottle because it's 0.33. All right, when we do the same thing for $8 divided by 32, 32 is going to be, multiples are going to be 32, 64, and if we kept going, we'd have 96 there. And I think we're going to need one more. Let's see. So if we add 32 again, add 2 is 98, plus 30 is 128. Let's see if that ends up being enough. So 80 divided by 32, 80 is between 64 and 96, so we're going to put a 2 up top, and then we're going to subtract 64 down below. That gives us 6, and then we're going to drop down a 0. Okay, after we've dropped down that 0, whoa, did you see what happened there? Forgot a 1. All right, everybody, what is 80 minus 64? That is 16, not just 6. So we have 16 left over, and then I drop down that 0. So now we need to know how many times does 32 go into 160. 160 is bigger than these multiples I wrote on the side, so I'm going to add a few more multiples. If I add 32 to 128, that is going to take me to 160. So now we have a big enough number. 160 is the fifth multiple, so I'm going to put a 5 up top. 5 times 32 is 160, so I subtract, I get a remainder of 0. And then I go ahead and put my decimal in my answer right before the 2 because it's right above the decimal in the dividend. So now we have our 2 unit costs. We have that Jackson paid 33 cents per bottle. Remember, the word per means to divide, so we divided money by number of bottles and got cents per bottle. And then we have that Steve paid 0.25 is 25 cents per bottle. So it's clear who got the better deal. Steve paid less per bottle. So Steve got the better deal, but the way we find out by how much better is we do 33 minus 25 to find the difference, which is 8. So we can say then that Steve saved 8 cents per bottle over Jackson. So Jackson didn't necessarily get a bad deal, but Steve got a better deal by 8 cents per bottle. All right, I know that was the longest one we've had so far. Hopefully you were able to stay with me through the whole thing. And that is the end of decimals. And that is also the end of the first section of this class. So hopefully you had fun with this one, and I will see you guys on the next one.